The rules for working with products and quotients of square roots can be extended to products and quotients of nth roots. Prime factorizations can again be useful as an aid for simplifying. And here we have stated the product rule for nth roots. The nth root of the product AB is equivalent or equal to the nth root of A times the nth root of B. And let's put that into practice here with simplifying this first example. They're asking us to take the cube root of 250. Well, let's break 250 down into a prime factorization. 2 times 125. And 125 can be broken down into 5 times 25. And 25 is 5 times 5. So here's our prime factorization, which would multiply to equal the radicand that we started out with, and then using the product rule, we're going to take the cube root of 2 times the cube root of the 3 5s multiplied together. We can't take the cube root of 2. There's only one factor here, and it's not a perfect cube in its prime factorization form. However, the cube root of 5 to the third power is 5. And customary, we do put our integers in front and our radicals second. Here is our simplified answer for this example that we just ran through. In the next one, they're asking us for the fourth root of 162. Again, we'll do a prime factorization. 162 is 2 times 81. 81 is 3 times 27. 27 is 3 times 9. And 9 is 3 times 3. Breaking this apart using our product rule then, this fourth root of this factorization is equivalent to the fourth root of 2 times the fourth root of, if we left it as our 81, or because we have the 4 3's multiplied together, we can clearly see that we have a perfect root here. The fourth root of 3 to the fourth power is 3. We'll move that out in front, and we only have 2 to the first power, a lower power than our index, and something that we can't simplify any further. So our final simplification of this radical would be 3 times the fourth root of 2.